Okay, so what is the equivalent derivatives of d over dx? Sine squared 2x, then cosine squared 3x. So let u is equals to sine squared 2x. Or we rewrite quantity sine 2x to the power 2. To find du, which is we apply chain rule. Okay? So remember, the d over dx, u to the power n u to the power n minus 1 du over dx. Okay? So, where du here is equals to, okay? So, wherein is 2, okay? Right, 2. Then, 2 minus 1, that is, we also write sine 2x. Okay? And then we derive this sine 2x. So apply this formula, d over dx, which is the sine u is equals to cosine u du over dx. Okay? So therefore, the derivative of sine 2x, that is cosine 2x. And then we derive also the 2x, which is 2 dx. Okay? So where du over dx is equals to 4 sine 2x cosine 2x. Okay? So another is, let v is equals to cosine squared 3x, or quantity of cosine 3x to the power 2. So where dv here is equals to 2 cosine 3x, okay? And then the derivative of cosine 3x, remember this formula, okay? So d over dx, which is cosine u, that is equivalent to negative sine u du over dx. Okay? So therefore, this is negative sine 3x. Okay? So we derive 3x, that is 3 dx. Okay? Then where dv over dx is equals to negative 6 cosine 3x sine 3x. Okay? So we can now use this formula, d over dx uv is equals to u dv over dx plus b du over dx. Okay? So substitute u here is equals to the quantity of sine 2x to the power 2, where dv over dx is equals to negative 6 cosine 3x, then sine 3x. Okay? Then plus, where v is quantity of cosine 3x to the power 2, then du over dx is equals to 4 sine 2x cosine 2x. Okay. And then simplify. This is negative 6. Quantity of sine 2x over 2. Then cosine 3x sine 3x plus 4 quantity of cosine 3x over 2, and then sine 2x cosine 2x. Okay? So Next, negative 3 quantity of sine 2x to the power 2 times 2 cosine 3x sine 3x plus 2 quantity of cosine 3x to the power 2 and then 2 sine 2x cosine 2x. Okay? So we apply the trigonometric identities. Okay? So which is sine 2a is equivalent to 2 sine e and then cosine e. Okay? In this case, where a here is 3x. The equivalent of this is equals to sine 2 times 3x. Okay? And that is sine 6x. From this is sine 2 times 2x. Okay? And that is sine 4x. Okay? So therefore, negative 3 quantity of sine 2x to the power 2, then write this sine 6x, okay, then plus 2 quantity of cosine 3x to the power 2, then write this sine 4x. Okay, so that is the final answer. Next, what is the equivalent derivatives of d over dx, the quantity of secant x, then tan x? Okay, so let u is equals to secant x. Okay, so take note that d over dx secant u is equals to secant u tan u du over dx. Okay, so therefore du here is equals to secant x tan x dx. Okay, so du over dx is equivalent to secant x then tan x. So another is v is equals to tan x. So apply this formula, d over dx tan u is equals to secant squared u du over dx. Okay, so we're dv here, and that is equivalent of secant squared x dx. Okay, so where du over dx is equals to secant squared x. Okay, so by applying this formula, which is the product rule, d over dx uv is equals to u dv over dx plus v du over dx. Okay, so where u is secant x, then where dv is secant squared x plus where v is tan x, then du over dx is secant then tan x, secant x then tan x. Okay, so we factor out secant x. Okay, So secant x times the secant x squared plus tan squared. Okay? So take note in trigonometric identities, secant squared x is equals to tan squared x plus 1. Okay? So substitute this. So secant x is equals to, or times the quantity of tan squared x plus 1 plus tan squared x. Okay? So secant x 1 plus 2 tan squared x. Okay? And that is the equivalent derivatives. Okay, so what is the equivalent derivative of d over dq secant cube q squared? We rewrite d over dq secant q squared to the power 3, or the quantity of secant q squared to the power 3. So let u is equals to secant q squared. Okay? By applying this formula, d over dx secant q is equals to secant u tan u du over dx, where du is equals to secant q squared tan q squared. And take note the derivative of q squared, that is 2q then dq. Okay. So where du over dq is equals to 2q secant q squared tan q squared. Okay. Okay, so by applying this formula or power law formula and differentiations of algebraic function, so d over dx u to the word n is equals to n u to the word n minus 1 du over dx. So wherein here is 3. Okay, so 3 u to the power 3 minus 1. So where du over dx, that is times 2q secant q squared tan q squared. Okay, is equals to 3 u squared times 2q secant q squared then tan q squared. Okay, so substitute the value of u, which is secant q squared, equals to 2 times 3, that is 6, then times the quantity of secant q squared to the power 2, then secant q squared tan q squared. Okay, or 6 is equals to secant q squared, or the quantity of secant q squared to the power 3, then tan q squared. Okay, so that is the final answer. Or also, secant 3q squared and tan q squared. Okay. Next problem, what is the equivalent d over dt, quantity of sine squared t over cosine t? Okay. Let u is equals to sine squared t or sine t or quantity of sine t over 2. So where du here is 2 sine t, derivative of sine, which is cosine. Cosine t dt. Okay? So where du over dt is equals to 2 sine t cosine t. Okay? And then where v is equals to cosine t. So dv here is equals to negative sine t dt. Okay? So where dv over dt is equals to negative sine t. And then we apply this formula, which is the quotient rule. D over dx u over v is equals to v du over dx minus u dv over dx over v squared. Okay? So substitute. Where v here is cosine t, where du over dx, that is 2 sine t, then cosine t, minus u is quantity of sine t to the power 2. So where dv is negative sine t, okay, over cosine t over 2. So simplify, is equals to 2 sine t cosine squared t over cosine squared t. So negative times negative, that is positive. So plus sine squared t times sine t over cosine squared t. Take note that the equivalent of tan x is equals to sine x over cosine x. The same as tan squared x is equals to sine squared x over cosine squared x. So this equivalent is tan squared t is equals to 2 sine t plus tan squared t, then sine t. Okay? So, or is equals to sine t 2 plus tan squared t. Okay? So that is the final answer. Next is, what is the equivalent of d over dz square root of 1 plus sine squared z, or d over dz, the quantity of 1 plus sine squared z to the power 1/2. So let u is equals to 1 plus sine squared z, then du here is equals to 2 sine z, then the derivative of sine, that is cosine z, dz. Then by applying this formula, d over dx, u to the power n is equals to n u n minus 1 du over dx. Okay? So, the problem given is in terms of z man, so we can change also into dz. Okay? So, substitute wherein is equals to 1/2. Okay? So, 1/2 u to the power 1/2 minus 1. Okay? So, where du over dz, that is equivalent of 2 sine z cosine z. 2 sine z cosine z. Okay? So, we can now cancel. So, u to the power 1/2 minus 1, that is negative 1/2. Then sine z cosine z. So, sine z cosine z over the 1 plus sine square z, or the quantity of 1 plus sine square z to the power 1/2 is equals to sine z cosine z over square root of 1 plus sine squared z. Okay, so that is the final answer. So next, what is the first derivative of d over dr, the quantity of r squared cosine 3r squared? Let du is equals to r squared, du is equals to 2r dr, then du over dr is equals to 2r, then let v is equals to cosine 3r squared. So, by applying this formula, d over dx cosine u is equals to negative sine u du over dx. So, where dv here is equals to negative sine 3r squared, then where d over dx is the equivalent of 3r squared, or the derivative of 3r squared, that is 6r, then dr. So where dv over dr is equals to negative 6r, then sine 3r squared. Okay? Okay, so by using this formula, d over dx, u v is equals to u dv over dx plus v du over dx. So, where u here is r squared, okay? Then dv over dx, that is negative 6r sine 3r squared. Then, plus v here is cosine 3r squared, then du over dx, that is times 2r. Okay, so is equals to negative 6r cubed sine 3r squared plus 2r cosine 3r squared. So this is the final answer.